Caught up? Monday, you know what I mean. Hopefully we'll be fully caught up. We're going to go over exponentiation today. We're going to go over exponentiation tomorrow as well. We're not going to start the homework this very minute, though. I'm going to actually do a little bit of finishing up from yesterday's lesson, a little clarification, and then we'll go into the homework from yesterday and today's lesson. What I want to get back to, and I want to make this point because it's unbelievably important for you. I want to make this point, but I also don't want you to get too wrapped up in it. So you're going to be tempted to talk like crazy about it, and I don't want that to happen because then we'll fall you a little further behind in understanding this exponentiation stuff. So don't go too nuts, but I want you to get a clear idea of exactly how all of this relates together. But please don't go too nuts with your comments and opinions. So here's the deal. I'm going to show you how to be rich. Guaranteed. And I mean that. I mean guaranteed to be rich. Okay? If you ever look at somebody like Paris Hilton, who, besides the fact that she's a very shallow human being, or at least what I see in the papers suggests she is a shallow human being. I shouldn't have said the first statement. There are kind of kids called trust fund babies. And the way a trust fund baby or a trust fund kid lives is somebody in their family puts money in a trust for them. And that money generates interest. And they actually make so much money every day in interest that you can't spend it all. So their money is constantly increasing. Now, to me, that's uber rich, super filthy rich, beyond anything that I could even conceptualize having. But for you and I, our relative level of richness is different. And it can work for every one of us. Now, my advice to you would be this. At your age, you should get a job. Some kind of job. I don't care if you cut lawns for the local neighborhood. I don't care if you babysit. I don't care if you do whatever you want to do, and that you save some of that money. At all costs, save the money. Do not give the money away. Do not spend it on things you think are important, like video games, the movies, etc., all of that kind of stuff. Spend some of it, but put most of it away. And I'm going to prove to you why, because you will be rich because of it. You are in 8th grade, almost 9th grade. I think it's very reasonable for you guys to put $5,000 away between now and the time you graduate high school. That's 5 years, roughly. It's $1,000 a year. That's not a lot of money. So, using the formula that we discussed yesterday, the amount of money in the account is going to be the principal times 1 plus the interest rate. I'm going to call it, we call it R, always as a decimal, to T, which is the number of years that it's going to be in there. Forget the end stuff. We'll get more into that later on. So, if you take $5,000 and you put it into your account, and you start working at age 20, you're going to put it in the account at age 18. And let's say you work until you're 60. I know that's a long time, but you're just going to leave it in the account until you're 60 years old. Does anybody know the average lifespan of a person in America today?
180.
75.
I think it's 79.
100 years.
No, I think it's 79. So if you retire at age 60, you should still be in good health. Okay? That means you don't have to work again for the rest of your life. And I want to see, how much money you have in your account. So I have a personal account with this fund called the American Fund. And there's a lot of money in that account. I started putting $15 a check away 32 years ago. And now I'm up to $300 a check. I've been doing it for 20 years. I just keep putting the money in the account. Every time I got a raise, I just put the raise in the account. I learned to live without the raise, or I kept a piece of the raise, but the rest of the money would go into this long-term savings account. I have a lot of money put in this account, and it's going to be what allows me to either get a really, really nice house on retirement, or to live very, very comfortably on retirement. So this is $5,000 as the principal, times 1 plus. Now my account has averaged 12.9% interest a year for over 90 years.
Oh my God.
So if I express 12.9% interest as a decimal, I get 0.129, and you're going to put it in when you're 18 years old, and you're going to retire when you're 60, which means it's going to be in there for 42 years. And you're just going to leave it. You're never going to touch it. So this is going to be, and you never had it, So it's not like you need it to live, okay? 5,000 times 1.129 to the 42nd power. Take your calculator. Type in 5,000 times 1.129 to the 42nd power, and tell me what you get.
Overflow.
What?
We got an overflow. What are we supposed to do?
5,000 times 1.129 to the 42nd power. Slow down. Just read me the numbers.
81679.9.
No, that's not true.
It's not 99. Oh wait, 'cause I
Is it 816,799?
Yes.
Yeah.
Point,
6,918.
point what?
6,918.
Oh
All
my
right.
God.
So
Yeah.
you just turned, by never touching it, you turned 5,000 into $816,000. Just make the money between now and the time you graduate. Babysitting, working at the beach, doing whatever you're gonna do. Put the money in the account, leave it there, don't touch it. You have $816,000, actually closer to $817,000. Now, aren't you going to make money between now and then?
Yeah.
Yes, you are.
So how much?
So that money also, you put a piece of that away.
401k.
And don't you make more money when you get older? So your potential to put more money away is very significant.
You could buy a countach with that.
A what?
A countach.
Whatever that is. Okay, now, this is how you get rich. You get rich by the miracle of what we call compound interest. Hey, it's the miracle of compound interest. It's a wonderful and a beautiful, awesome thing. If you're making the money. It is a damning thing if you are spending the money. Let's say you have a credit card. Credit cards are often, high interest is 22%. So let's say on your credit card that you borrow let's say you borrow 5,000 because you just have to have the clothes. You just have to have the stereo system. I can't live without the trip to Cabo San Lucas. The amount of money you will owe on the credit card is 5,000 times 1.222, and they often in credit cards, they figure it out based on taking 10 years to pay it back. Figure out how much money you owe then.
I don't want to.
No, you don't.
So if you borrow from a credit card.
So you borrow 5,000, tell me what you pay for it.
Oh my God.
Go ahead, talk to me. What do we got?
36,523.
Now,
157.
Now, here's the deal. You go to the store. Sale! 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 You see the dress, you go, oh my God, oh my God, oh my God, I gotta have the dress! Oh! And you go buy the dress, you go, oh my God, it's 50% off!
How about
I'm only
that?
spending $100.
How
And
about
then
that?
you add up how much you spent on your credit card.
Oh my God.
Yes! That's the oh my God moment. Now, here's the beautiful thing. You pay cash for the dress.
Then you don't have to.
You don't have to pay any of the money here, and the money that would have went to this goes where?
To your bank account.
Yes, and then we do another one of these.
So
Yay!
basically,
And then we put this away.
More
And then we
money.
get, yes, more money. This is how rich people think. Rich people don't go, oh my God, I gotta have the dress. Rich people wait until they have the money in the
Oh
account.
yeah, because the trust.
But
fund
what do
pays
you
for
see?
that.
You see Paris Hilton and the trust fund babies running around going, oh
I
my
have
God,
to have
darling, I can have my little chihuahua in my pouch, and look at me, look at how I'm dressed, I am divine. This is not the way the world works. And the minute you fall into that trap, you become the person who's paying forever. One last thing, if you want to respect your parents, very, very, very quickly. Let's talk about buying a house. Okay? How much does it really cost to buy your house? Now, here you go, ready? Let's just say, for argument's sake, that I'm going to sell my house in a few years. Actually, I'm going to sell my house in 15 months, 18 months. I sell the house. I want to get $300,000 for my house. Let's say the people are very nice and very good, and they put $40,000 down, so they borrow $260,000. Right now, the interest rate on the house is about 5%. It's a little bit under, but let's call it 5% by then. So it goes to 1.05. Most people take a 30-year loan. Figure it out. How much money do you really pay for the house?
That's a lot. That's a lot. That's a lot. That's $1 million. That's over $1 million.
There we go. Tell
Oh
me
my
what
God.
I
I'm gonna be homeless now.
What do we get?
$1,122,705.01.
I think we can care less about
And
this.
1 penny.
And 1 penny, okay. Now, hold it. If you wanna know why your parents get upset about having to pay a mortgage, all right? Now, wait, we gotta go better. You ready for this?
Absurd.
Now, hold it. Hold it. Divide that by 360. That's your monthly payment. How much is the monthly payment?
$3,121. $3,000 a month. How much are you making?
No, it's actually more than that though, because you have taxes.
Oh my God.
Taxes, insurance will be about $800 a month.
And utility costs.
So that's well, that's different. $3,921 to live in that house. So the next time your parents tell you to do something, shut your mouth and do what you're told. With 3,921 reasons every month to make sure you do what you're told. Yes.
Especially if you're buying.
Well,
Property taxes.
this is for people who are buying houses now, like you.
already know that.
People my age who bought it are probably spending about $2 grand.
It would
Right?
still be as much.
Now you know why I want off Long Island. Okay,
Actually, no.
So- hey,
Property taxes.
remember when I said the temptation to talk is going to be there, and I really don't want that? Okay, so very quickly, I want to go over the homework, and I want to get the homework gone over in no more than 3 minutes. Okay, last night's homework, the first 3 quadratic equations. Please, please, please tell me you got letter C right. It's far and away the easiest one there, as long as you recognize that you're supposed to find the common factor. Look both ways before you cross the road. Find the common factor. Kaylee. Oh yeah, all right. Ding, 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 ding. The Linquist Daily Dumb Mistake. 14 it is. Yeah, I just forgot to copy it over. You know the drill, guy. Hey, stop. You don't get in your own way here. You know the drill. The drill is that I do these during extra help, and I just make careless mistakes because I'm helping kids at the same time. Okay. Here are some arithmetic geometric sequence type of questions. Remember, recursive means recurring or repeating. So you define what the first one is, a sub 1, and then you list whatever the pattern is that gets you from one number to the next number. Any questions on 6 or 8? Okay, I'll scroll up. Spencer?
Oh, no.
All right, I'll scroll up to here. Okay. Any issues, any problems? Okay, let's go to the other page of the homework. I highlighted on this quadratic equation question here because I was helping today, and some people, I've seen this twice so far. I saw it today and I saw it the other day, where kids think you kind of distribute the -4 here. There's no distributing. This is a number times a number times a number. It just so happens one of the numbers is negative. So it's just -4 times 1 times -3, which is a positive 12, and 64 plus 12 is 76. Okay? Quite the pen you got there, Catherine.
It's not a pen.
It's not a pen?
No.
Okay, quite the thing you got there. All right. And I didn't think our class yesterday was very, I I don't think it went perfectly because we didn't get enough reps in, but if you look at the homework here, there's a lot of reps that are very good. It's the principal is the initial balance times 1 plus or minus the interest rate, which in this case is, I'm adding it because it's going in the bank to accrue, and then to the number of years. So, and you can see the only thing I'm changing in each of these problems is the number of years. Okay? And then likewise, with the number 5 at the bottom, the only thing I'm changing is the number of years. So you see the pattern. You see the pattern is always the principal never changes, the interest and the rate never changes. The only thing that changes is the numbers of years. Okay? Any questions on these? All right, so let's go to today's lesson sheet. And we're going to talk about exponentiation, which is very closely related to the work in interest. Interest is a specific application of exponentiation, and exponentiation is whenever the variable, in this case time, is found in the exponent. And we did some work earlier this year with exponential functions. You remember how they're graphed, right? How does an exponential function look when you graph it? Come on, how's it go? Anthony?
It's going up and up and up and up and up.
Yeah, it goes up really, really, really fast, and we're going to show you a little bit about why. So if that was the axis, exponential functions will go up something like this.
Exactly.
And that's right, and that's why the money makes so much money. Once you get your interest rate, if you leave the money in there long enough, you get to a certain point, and it's just growing so fast that your money gets really, really huge. Putting away that $15 a check when I started, and then it became 25, then it became, I remember a big jump to 50, and then I worked it all the way up to 300 a check. I've never had the 300 a check, so I don't miss it. Sure, I like $600 more a month, but I have this account with this money set away, and when we retire a year from June, I have 2 big options. My first big option, because I put that money away, is that I can buy a house, take a mortgage on that house. Well, first off, I'm going to sell my house, and I'm going to make approximately $200,000 on the sale of my house, a little bit less. When I sell the house, I can either buy a house for $200,000 and not have a mortgage, which means I don't have those huge payments, or I can take that $200,000, put it down on the house, take the money that's in that account, earn interest on that money in the account, and then take the payments on interest and pay the monthly payment with the mortgage on the new house. Which way I'll go? I don't know. If I find the perfect house on the perfect river with the perfect trout fishing, I'll probably buy the big house. Otherwise, I'll buy a smaller house and I'll take that money from the account and I will go places and do things, okay? All because it's exponential. And once I hit this point, that money grows so fast that that's what allows me to do it. That's how the stock market works as well. All right, radioactive substance decreases. This is a little new. Decreases in the amount of grams by 1/3 each year. If the starting amount is 1,452, write a recursive formula or sequence that models the amount left after each year. Is it arithmetic or geometric? Well, the first thing is it's going to be geometric because I'm not adding or subtracting, I'm multiplying by 2/3. So if I start with 1452, I'm then going to do 2/3 of 1452. Can somebody on your calculator do 2/3 times 1452? Tell me what you get.
Wait, two, three times what?
968.
968? Yeah, and then it's just 2/3 times it every time because that's what it says here. It's reduced. Let me rephrase this, ready? If it decreases by 1/3, what third remains?
2.
2/3. That's why I'm multiplying by 2/3. So what's 968 times 2/3?
645, 20.
With what?
3, so it's 1/3.
6 what?
645 and 1/3.
645 and 1/3. Now, multiply that by 2/3.
430.
430?
0.2 repeating.
Point.
2 repeating.
So that would be 2 ninths. Okay. So if I did a recursive formula, I would say the new term, a sub n plus 1, is equal to 1452 times 2/3, the common ratio, to the n minus 1 power, to the, you know what? No, I take that back. It's equal to 2/3 times a sub n. I was mixing up my explicit formula with my recursive formula. For the recursive one, the new term is 2/3 of the old one. And I also have to list that my first term is 1452. So first term's 1452, new term is 2/3 times the old term, okay? Any questions? Okay, very, very quickly, an example of exponentiation. Growing up as a kid, my dad gave me two choices.
Do you legitimately offer you these?
Yes, this is something he actually did. I actually think it was $5 a week. I don't think it was $10 a week. But my dad comes up to me one day and he says, I was begging for allowance. And he says, listen, all right, I'll give you allowance. I'll give you a choice. I think he said $5, but we'll go with that. He said, I'll give you $10 a week for the month. Or he said, I'll put a penny on your dresser. And then I'll double the number of pennies on your dresser every day for the month.
My dad asked me this question.
So, yeah, so he says, what happens is, which do you want? I said, oh, I'll take the $10 a week. He goes, you chose wrong. Now, I was only in like 6th grade at the time, 7th grade. He said, what do you mean? He said, if you chose the pennies, it'd be over $1 million at the end of the month. It is. I think it's actually over $2 million at the end, if it's a 31-day month, okay? And the way you do it is, for the first choice, it's not exponentiation. It's $10 per week.
Or 10x.
So you're literally going up 10 every week. 10, 20, 30, 40, and then you would start all over again because the month you would have a new month in it. This becomes 2, and in a month there's 31 days. If you just do 2 to the 31st power, that will tell you how many pennies there are. It's actually 2 to the 30th power because the first day there's only 1 penny on it. But if you do 2 to the 30th, I think it comes out to close to 2.5 million. All right, 2.38 million, something like that. All right, so obviously the best choice would have been,
billion. I got a billion.
yeah, but you have to divide by 2, move the decimal 2 places because of change.
5,300,000.
All right, very quickly.
What's fixed?
Did you actually get any of it?
No, God no. No, my dad was not very good about honoring what he said he would give me. All right, now let's take a look at how exponentiation grows and how quick it can go. Ready? If I do f of n is equal to 2n, God bless, there's my graph. F of n is equal to 2n. It's a linear function with a slope of 2. If I do exponentiation, I'm going to get 0.25, 0.5, 1, 2, 4, 8. It looks like this. And this is exponentiation, f of n equals 2 to the n. Obviously, for a little while, just like with the money on the dresser, you're ahead if you're 2n. But once you get to a certain point, the other one gets so much bigger, so much faster, that exponentiation gets much, much larger. Okay? So exponentiation is whenever you have the variable where. Where's the variable go when we have an exponential function, guys? Let me repeat that. We have an exponential function. Where does the variable go?
The exponent.
The exponent. And as soon as you see that, you know that it gets very big, very fast. And by the way, you know, an example of things that are exponential is population. And if you want to know why cancer can be so difficult, there's very few cancer cells in your body, so you never really see them. But once they explode to a certain point, the word is metastasize. They spread through your body and then they overtake you. And that's what gets you. So tomorrow we'll talk about some applications of exponentiation. You know what I mean. Monday. Hasta la vista. Bye con Dios. Toodaloo. Ta-ta. Arrivederci. Smile a lot. Ciao. Wiedersehen. Adios. Amigos. Amigas.
Because I'm quarter Irish.
Oh, is that why? I gotta work and I'm half Irish.